Alright, so this time I'm solving problem 1 from chapter 7, and the question says, in one day, a 75 kilogram mountain climber ascends from 1500 meter level on a vertical cliff to the top at 2400 meters. The next day, she descends from the top to the base of the cliff, which is at an elevation of 1350 meters. What is her change in gravitational potential energy, A, on the first day, and B, on the second day? So, let's write down what the problem tells us. It tells us that the mass of the hiker is 75 kilograms. We know that the initial starting height, or X position, is 1500 meters. Y2, the second Y position that it gives us, is 2400 meters. And then the third Y position is 1350 meters. It then wants us to find the change in potential energy as the hiker travels to the different distances. So, you know that the potential energy, day 1, is going to be equal to, so we know that the change in the gravitational potential energy is going to be the second potential energy minus the initial. So for day 1, it's going to be, and then these can be rewritten as the mass times gravity times the height, or in our case, y. So you can then rewrite that as the mass times the gravity is going to be equal to y2 minus y1, because the mass and gravity are going to be the same for both of them. The hiker is still going to weigh the same, and we're assuming gravity is going to have the same force. So we then plug our variables in. 75 kilograms times 9.8 times the second height, 2,400 meters, minus the first height, 1,500 meters. And so that becomes 75 times 9.8 times 1, so 600. And then when you do the math, you find that the change in potential energy as the hiker goes from this height up to this height. Change in potential energy is an increase of 6.6 times 10 to the 5th joules. So that's your answer for part A. Part B wants us to do the same thing, but when the hiker goes from the top of the cliff down to the base. So for B, our setup will be the same. The change in the potential energy from gravity, but it'll be U3 minus U2, which can also be written as mass times gravity times Y3 minus Y2. And then, so the mass is still the same, 75 kilograms times 9.8 times Y3 is 1,350 meters minus Y2 2,400 meters, which gives us, and you do the same thing, and when you do the math, you get the change in energy going from the top of the cliff to the base is negative 7.7 times 10 to the 5th joules. And that's your answer for part B.